Hi, I am Dr. Shubhangi Vaikure, working as a associate professor in computer department at the Tamigi College of Engineering. So in the AISC subject, totally we are having the 6 topics. The first topic related to the introduction to AI. The second topic is related to the problem solving. What are the different agents that are used to solve the problems? The third topic is related to the knowledge base agent, the reasoning and planning. The fourth chapter is about the fuzzy logic. The fifth chapter is about the artificial neural network. And the sixth topic is about the expert system. So today we are going to see the first chapter, that is Introduction to Artificial Intelligence and Soft Computing. Now let us see what is this chapter about. So the first chapter contains the 3 topics as Introduction and Definition of Artificial Intelligence. The second is the intelligent agents, and the third one is soft computing. So today we are going to cover the first topic, that is Introduction and Definition of Artificial Intelligence. This topic contains the introduction to AI, then categorization of the intelligent systems, then we will see the history of artificial intelligence, then what are the different components of AI programs, then we'll see the foundations of AI, then sub areas of AI, applications of AI, and current trends in AI. So let's start with the artificial intelligence. So we can define the artificial intelligence as it is a branch of computer science that deals with the study and creation of computer systems that exhibit some form of intelligence. The intelligence exhibited by machines, academic field of study which studies how to create computers and softwares that are able to show intelligent behavior, comes under the artificial intelligence. Yes, but what is intelligence? So naturally, the types of intelligence covers various topics, that is naturalist, understanding living things and reading nature. So as a human being, we are able to understand the living things. We are able to understand the nature, or we are able to gain the knowledge from the environment. Musical, discerning sounds, their pitch, tone, rhythms, and timbre. We are able to differentiate between them. Then logical, mathematical, that is, we are able to quantify things. We make hypotheses and prove them. Then existential, tackling the questions of why we live and why we die. So we are able to focus on the existence of some things, and we are able to also recognize the reason behind that. Then interpersonal, sensing people's feeling and motivates. Yes, as a human being, we are able to understand one's behavior, his feelings, his motivation. Then bodily, kinesthetic, coordinating your mind with your body. Then linguistic, finding the right words to express what you mean. So we are able to express our feelings with the help of the words or with the help of the language. Then intrapersonal, understanding yourself, what you feel and what you want. So we are able to coordinate between them. Then spatial, visualizing the world in 3D. So these are the different areas of intelligence. So in AI also, we covers the integrated sum of all knowledge and the fits acquired through the environment. It is a computational part of the ability to achieve goals. Then what are the formal definitions of artificial intelligence? The computational models of human behavior? Yes. The programs that behaves exactly like human is nothing but the artificial intelligence. Then computational models of human thoughts? Yes. The programs that operate the way human do. So as a human, if we are able to do something, then artificial intelligence program can be able to that program. Computation system that behaves intelligently. What does mean behave intelligently? Do machines have IQ? The machines does not have IQ by itself. But to make the machine intelligent, we have to program that machine. Computational system that behave rationally. What is AI? The science of making machines that are able to do all these things. So we can define the AI as the study and design of intelligent agents, in which an intelligent agent is a system that perceives its environment and take actions that maximizes its chance of success. Now, AI can be weaved into four categories, that is called as the categorization of AI. So we can say the AI is divided into the four dimensions. The first dimension is the system that think like human, the system that think rationally, the system that act humanly, the system that act rationally. So there are four dimensions. The top dimension represent the thought or the reasoning dimension. The low part represents the behavior dimension. The left part represents the major success against human performance, and the right part represents the major success against idea, concept of intelligence. So now we'll see this four categorizations one by one. So the first one is acting humanly, the system that acts like human, that is behavior and human performance. Now, what is the meaning of system that act like humans? The art of creating machines that perform functions that require intelligence when performed by people. Or we can also say the study of how to make computers do things at which, at the moment, people are better. We can give the examples of this system like Turing machine. Can machines think? Can machines behave intelligently? Yes. If we take the example of the Turing machine, it does that. A computer passes the test if a human interrogator, after posing some written questions, cannot tell whether the written responses come from a person or from a computer, then the Turing machine can be said to pass the test. So in this diagram, we can see at the left part, there is a human interrogator, and at the right side, there is a human and an AI system. So acting humanly Turing test. How this Turing test is done. So a test based on indistinguishability from undeniably intelligent entities, that is human beings. The computer passes the test if a human interrogator, after posing some written questions, cannot tell whether the written responses come from a person or not. So here we can see the example of a Turing test. Here we ask the questions and the machine answers. If we are able to tell that if the answer comes from a machine, then it is failed. If we are not able to answer whether it response comes from a person or not, then the Turing test is said to be passed. So for a computer to pass the Turing test, which capabilities it needs to possess? So the first one is the natural language processing. To enable it to communicate successfully in English. So the Turing test needs to communicate, and for this communication, it requires the natural language processing. Then the next characteristics or the capability is the knowledge representation. The knowledge which is stored in that machine is stored in form of certain format, and that is called as the knowledge representation. Then automated reasoning. This is used to use the stored information to answer questions and to draw new conclusions. Then machine learning. It is used to adapt to new circumstances and to detect and extrapolate patterns. Then computer vision. To perceive the different objects, the computer vision is needed. Robotics. To manipulate the objects and to move that objects, we require the robotics. So to pass the total Turing test, we need all these things. Say that Searle, as a philosopher investigating in the nature of mind and consciousness, these are the relevant mysteries. The Chinese room is designed to show that the Turing test is insufficient to detect the presence of consciousness even if the room can behave or function as a conscious mind would. So can a machine be intelligent? Have beliefs? Have a mind? Those who support strong AI and the strongest forms of functionalism argue that a machine with a digital computer and the right kind of computer program could have a mind. One of the most famous attacks on this view is John Searle's Chinese room argument. So the Chinese room argument is designed to carry out experiments on the Turing test. So the experiments are conducted where the interrogator asks various patterns, various questions to the Turing test, where the Turing test fails. So sitting in the Combat Information Center aboard a warship proposed as a real-life analog to the Chinese room. So we have seen the example of the system that act like humans. Now we'll see the next category, that is the system that think like humans. Thought process, human performance, and reasoning. It contains the cognitive modeling approach. The existing new effort to make computers think, machines with minds in the full and literal sense, is called as the system that think like humans. The automation of activities that we associate with human thinking, activities such as decision making, problem solving, learning, comes under this kind of systems. For this system, we need to get the insight, the actual working of human minds, introspection, psychological experiments, observing the brain in action. Once we have a sufficiently precise theory of the mind, it becomes possible to express the theory as computer program. If the program's input-output behavior matches corresponding human behavior, that is evidence that some of the program's mechanisms could also be operating in human. I will see the example of the system as cognitive science. If we say given program thinks like human, we must have some way of determining how human thinks. We need to get the inside the actual working of human minds, the two ways as we already seen, introspection and through psychological experiments. Once we have a sufficiently precise theory of mind, it becomes possible to express the theory as a computer program. The interdisciplinary field of cognitive science brings together computer models from AI and experimental techniques from psychology to try to construct precise and testable theories of the working of human mind. So the field that brings together computer models from AI and experimental techniques, from psychology to construct precise and testable theories of the human mind comes under the cognitive science. Then we'll see the next categorization of AI, that is the system that thinks rationally. The study of mental faculties through the use of computational models. Or we can also define this as the study of the computations that make it possible to perceive, reason, and act. So we can give the example of thinking rationally system as the laws of thought approach. The laws of thought approach is the provided patterns for argument structures that always yield correct conclusions when given correct premises. So we can give the example, suppose Ellen is a man, all men are mortal. Therefore, Ellen is mortal. So this kind of association between the Ellen, the man, and the mortal is done, and the conclusion is drawn as the Ellen is mortal. Aristotle was one of the first who attempted to codify the right thinking, that is, irrefutable reasoning process. He gave syllogisms that always yield correct conclusion when correct premises are given. So based on the correct premises, the correct conclusions are drawn and the system can think rationally. Now we'll see what is logic. So these laws of thought were supposed to govern the operations of the mind. Their study initiated the field called logic. The obstacles to this approach are, it is not easy to take informal knowledge and state it in the formal terms required by logical notations, particularly when the knowledge is less than 100% certain. There is a big difference between solving a problem in principle and solving it in practice. Now, the next categorization of AI is acting rationally. The computational intelligence is the study of the design of intelligent agents. AI is concerned with intelligent behavior in artifacts. So acting rationally, we can give the example of the rational agent approach. The rational behavior means doing the right things. The agent which do the right things is called as the rational agent. The rational thing or the right thing is which is expected to maximize the goal achievement given the available information. So suppose we have to perform some task, then we need to give some information, and the information whatever is available with that agent, if that agent is able to perform that task with the maximum goal, then we can say that the right thing is happening and the agent is rational. So here we see the structure of the rational agent. Rational agent perceives the environment through the senses and acts on the environment through the effectors or through the actuators. So an agent is just something that acts. A rational agent is one that acts so as to achieve the best outcome, or when there is uncertainty, the best expected outcome. So this is the rational agent that acts to achieve best outcome even there is uncertainty and provide the best expected outcome. It is more appropriate approach for scientific development than approaches based on human behavior and human thoughts, because the standard of rationality is clearly defined and completely general. Now we'll see strong AI versus weak AI. Now what is weak AI? Weak AI only claims that machines can act intelligently. So here we are assuming that the machine can act intelligently. Machine intelligence need only mimic the behavior of human intelligence. So if as a human being, if we are able to perform some task, then we assume that the machine is also able to perform that task. Not intended to match or excel the capabilities of human beings. So here we assume that the machine is not able to match the capability of the human being, or the machine cannot exceed the performance of the human being. Then what is the strong AI? The strong AI claims that a machine that acts intelligently also has mind and understand the same sense people do. So here we can give the example of certain robots, that robots are able to understand the mind of the peoples also. We can say the example of the Turing test. The Turing test responds intelligently to the questions of the human beings. And given the appropriate programming, a computer actually becomes a mind. So if we want the machine to perform a certain task, then we have to program that machine accordingly, and we can see that now the machine has a mind and that machine is able to do that assigned task properly. AI that matches or exists human intelligence. Yes, here now we are assuming that the AI or the machine is able to match the performance or the capability of human intelligence. Not just match, sometimes it can exceed the human intelligence. So these are the assumptions of the weak AI and the strong AI. Now we'll see the foundations of AI, the disciplines that contributed ideas, viewpoints, and techniques to AI. So here, the first in 428 BC present, the philosophy comes. The philosophy contains the logic, methods of reasoning, mind as physical system, foundations of learning, language, rationality. So what it studied? First one is, can formal rules be used to draw valid conclusions? As we have already seen, when we give the correct premises, so based on that correct premises, the valid conclusions can be drawn. So first it is studied that, are we able to design these formal rules? Then it is studied that how does the mind arise from a physical brain? So brain is a physical thing. So from this brain, how the concept of mind comes, it is studied. Where does knowledge come from? So as a human being, we perceive the knowledge from the environment, the activities we do, or what we learn. Then how does knowledge lead to action? So how this accumulated knowledge is used to perform certain actions. So all these things are studied under the philosophy. Then next one is mathematics. It comes in the 800 decade. So in the mathematics, it represents the formal representation and proof algorithms, computation, decidability or undecidability, tractability or intractability, and the probability. So here they studied that what are the formal rules to draw valid conclusions. Yes, again it is studied in the mathematics also. Then what can be computed? So actually it is seen that what are the different tasks or what are the different problems that we actually able to perform. Then how do we reason with uncertain information? Yes, sometimes we do have the less information or the information is not proper. So are we able to reason depending on that uncertain information? And also logic, computation, and probability is studied under the mathematics. The next one is the economics. It is in 1776. Here, it is studied at utility and the decision theory. So how should we make decisions so as to maximize the payoff? So whenever we have to perform some tasks, always our aim is to maximize the profit or you maximize the output. So what will be our plan of action or what will be our decision so that our performance or our output gets maximized? How should we do this when others may not go along? Yes, certain times there are conflict. Some people doesn't support. Then based on this situation, how we should do, that is studied in this economics. Then how should we do this when the payoff may be far in the future? We can give the examples. Suppose we want to develop some business, then initially we have to invest, but we are not able to see the immediate benefit. So how should we do this when the payoff may be far in the future? It is also used for the rationalization for the optimal solution. The next one is the neuroscience. It is in 1861. It contains the physical substrate for mental activity. So how do brain process the information? The brain is what? The brain is the nervous system. The brain captures the information from the environment. Then this captured information is processed inside the brain. In the human brain, we are having the neurons. Neuron is what? Neuron is an elementary nerve cell which is having the information processing capability. The neuron is divided into the different parts, and that different parts are used to process this information. That is studied under neuroscience. Then next one is psychology in 1879. It studies phenomena of perception and motor control, experimental techniques. How do humans and animals think and act? This is studied under the psychology. Then next comes the computer engineering, 1940, building fast computers. How can we build an efficient computer is studied under this. Then next one is the control theory. The control theory and the cybernetics. It comes in 1948. It is a study that designs system that maximize an objective function over time. So how can artifacts operate under their own control? In 250 BC, the first self-controlling machine is built, which is a water clock with a regulator that kept the flow of water running through it at a constant predictable pace. Previously, only living things could modify their behavior in response to changes in the environment. So here it is studied that how a machine will behave under the control environment. The next one is the linguistic, comes in 1957. It is a study that contains the knowledge representation and grammar. So how does a language relate to thought? So as a human being, suppose I want to express certain things, then I use my knowledge, my known knowledge to express my thoughts. So how does this language is related to thought is studies in the linguistic. The linguistic and artificial intelligence bond together, and their hybrid is called as the natural language processing, because in order to understand the language, we need to understand the subject, context, sentences, and not only the structure of sentences. So these are the foundations of AI. Now we'll move towards the history of AI. What are the different steps under the history of AI? So first comes the gestation of AI in 1943 to 1955. The first work that is now generally recognized as AI was done by the Warren McCulloch and Walter Pitts. The model designed by them is called as the McCulloch and Pitts model. Now, as a human being, we capture the knowledge from the environment, and this captured knowledge is processed inside the brain, and according to the processing, the human reacts. So the same thing is implemented artificially, and that is called as the McCulloch and Pitts model. So in the brain, the neurons does this work. The neuron is divided into the parts as the axon, the dendrite, and the cell body. So what axon does? The axon is what? The axon is the output fiber. The dendrite is the input fiber, and inside the cell, the information is processed. So in the human brain, there are different electrochemical contact organs are present, and based on that electrochemical contact organ, the chemical is generated, and based on that chemical, the human reacts. So the same thing is implemented artificially. So if we see this diagram, the input signals are nothing but the dendrites. So X1, X2, X3, X4, these are the inputs. These inputs are given to the information processing. So if we see here, this WK1, WK2, WK3 and WK4, this represents the weight. So weight is what? The weight is nothing but the acquired knowledge. So in the human brain, the acquired knowledge is stored in the synapse. In the artificial neural network, the acquired knowledge is stored as a weight value. So whenever we provide any inputs, that input is multiplied with the weights, and then that signal is given to the summing junction. Now here in this diagram, we are able to see the term called as the bias. The bias is the extra input which is provided to the network to enhance the performance. Now in the summing junction, this X1 into WK1 plus X2 into WK2 plus X3 into WK3 plus X4 into WK4 plus this BK is added. And that summation is called as the net input to the network. Then on that net input, we apply the different activation functions. Now, what is the activation function? The activation functions are the functions which are used to convert the given input to the output. So it is nothing but the interpretation of the local input in terms of its output. So in 1943, the first ANN model by McCulloch and Pitts is generated. Then in 1949, the Donald Hebb demonstrated a simple updating rule for modifying the connection strengths between neurons, and that is called as the Hebbian learning rule. Connections between two neurons might be strengthened if the neurons fire at the same time and might weaken if they fire at different times. The Hebbian learning rule is basically a unsupervised learning rule. So based on the input and output relationship, the output is predicted. Then in 1950 to 51, Marvin Minsky and Dean Edmonds built the first neural network computer in 1950 called the SNARK, the simulation of rat finding out way through a maze. So this network model is designed consisting of a maze and where a simulation is done. In 1950, the Turing test developed by Alan Turing is developed. We have already seen what is Turing test. It is a test of machine's ability to exhibit intelligent behavior equivalent to or indistinguishable form that of a human. The birth of artificial intelligence is done in the Dartmouth Conference by John McCarthy. The Dartmouth Conference is conducted by the founding fathers of AI, John McCarthy, Marvin Minsky, Claude Shannon, Ray Solomon, Alan Neville, Herbert Simon, and Arthur Samuel. Here, this workshop is conducted and the name is given as the artificial intelligence. The early enthusiasm and the great expectations are there in 1952 to 1969. Few years earlier, computers were seen as things that could do arithmetic and no more. It is assumed that a machine can never do a X task. Then AI researchers naturally responded by demonstrating one task after another. So the development is physical symbol system, then Lisp, microworlds, Adeline, perceptron. In 1959, McCarthy published a paper entitled Programs with Common Sense, in which he described the advice taker, a hypothetical program that can be seen as the first complete AI system. In the 1959 to 69, as we already seen, it is assumed that a machine cannot perform a particular task. Then the AI researchers work hard towards the execution of that certain task. So the James Taggle-Sent program in 1963 was able to solve the closed form calculus integration problems. Then Tom Evans' analogy program in 1968 solved geometric analogy problems that appear in IQ test. Daniel Bobro's student program in 1967 solved algebra story problems. So one by one, the AI researcher comes and they prove that this task can be performed by the machines. Then the block world problem is designed by D. Shadru in Winograd 1972. If you see this diagram, then in this diagram, A part represents pick up a big red block. Then find the block which is taller than the one you are holding and put it into the box. Then will you please stack up both of the red blocks and either a green cube or a pyramid. So a machine is able to solve this block world problem. And in 1966 to 1973, a dose of reality is observed. So early experiments in machine evolution, now called genetic algorithms, perceptron rule, backward propagation rule in neural networks. Within 10 years, a computer will be a chess champion predicted by Simon in this era. These predictions came true within 40 years rather than 10 years. The overconfidence was due to the promising performance of early AI systems on simple examples. As we have seen, the researchers comes and they have executed certain problems or they have executed some tasks, and due to this confidence, they assume that yes, now AI system is able to perform anything. These early systems turn out to fail miserably when tried out on wider selection of problems and on more difficult problems. And in 1969 to 79, the expert systems are designed. Now, what is expert system? In the expert system, the knowledge is stored in the form of the rules, if-then rules. So we acquire the knowledge from the expert, and that knowledge is converted into some knowledge representation, and that is stored in the knowledge base. Then from that knowledge base, the inference engine takes the knowledge and that is used to provide the solution to the non-expert users. So the non-expert users ask the query with the help of user interface, then that query is given to the inference engine, then inference engine try to find out the match between the user query and the knowledge which is stored in the knowledge base, and whenever there is a match, then that answer or then that conclusion or the advice is given to the non-expert user. Then 1980 to present, AI becomes an industry. Yes, now we can see everywhere there is a use of artificial intelligence. 100 startups using artificial intelligence to transform industry started in 1980. So there are various systems or various industries such as the conversational AI or the bots, vision systems, the auto system, the robotics, cyber security, business intelligence and analytics, AD, sales, CRM, core AI, text analysis generation, IoT, commerce. Now every industry makes use of AI. Now here we will see the history of AI. So we have seen the history of AI. Now next one is the applications of AI. There are various applications of AI. So areas of focus for firms looking to exploit the AI opportunities. The areas are data science, business intelligence, health plans and patient care, computer vision, speech recognition, aerospace and defense, natural language processing, and entertainment. There are various AI-based applications in different fields. Virtual assistant. If you take the example of the Amazon Alexa, Google, Cortana, Siri, these are the virtual assistant that make use of artificial intelligence. The next one is the robotic vehicles. Also, one hip now uses some computer vision techniques to create a 3D model of a patient's internal anatomy and then uses robotic control to guide insertion of a hip replacement prosthesis. So the robotics can be used in medical field also or in the automobile industries also. And game playing. IBM's Deep Blue Chess is one of the example of the AI game playing. You can play various games using the artificial intelligence. The next one is the speech recognition. You can able to recognize the speech is coming from X person or the Y person, or the machine is able to recognize the speech given by humans, and based on that speech the machine reacts. Then computer vision. If in computer vision, certain objects can be tracked or detected using the artificial intelligence. Then surveillance and security. Yes, again in surveillance and security, the AI can be used. And in military applications also we can use the AI. In machine translation, that is Google Translate. If we give a text in one language, then the machine translation will convert that text into the another language. Then chatbots. Chatbots, here the human asks some questions and the chatbots, based on the knowledge which is stored or based on the database which is already stored in that chatbots, reacts to the user's query. And medical and healthcare. Again, in medical and healthcare, we can use the various AI techniques. Then logistic and supply chain. In logistic and supply chain also, we can use the AI techniques. In autonomous planning and scheduling, the NASA's remote agent program to control and schedule operations for the spacecraft. This is one of the applications of the AI. Then autonomous control, Alvin. The computer vision system was trained to steer occur to keep it following a lane. A particular lane is followed based on the computer vision system. Then that is called as the Alvin application of AI. Then also we can design the expert system or a diagnosis expert system called as MySyn, where the symptoms are given as the input. Then based on that symptoms, the disease is predicted and certain precautionary actions are suggested to the users. Then in logistic planning, the DART, that is dynamic analysis and replanning tool. The DART is dynamic analysis and replanning tool. Here to do automated logistic planning and scheduling for transportation, the AI is used. For language understanding and problem solving, also we can use the AI. Proverb is one of the application that uses to solve the crossword or the puzzle program. So these are the different applications of AI. So in the first chapter, first topic, that is introduction to AI, we have seen what is AI. So AI is what? The AI is a study and design of intelligent agents in which an intelligent agent is a system that perceives its environment and take actions that maximizes its chances of success. Then we have seen the different dimensions of AI, that is categorization of AI. So system that think like human, system that acts like human, system that thinks rationally, the system that act rationally. Then we have seen the foundation of AI. In this, we have seen the philosophy, mathematics, economics, neuroscience, psychology, computer engineering, and linguistic. Then we have seen the AI, how the AI has evolved from 1943 to present. Then we have seen the various applications of AI. So this is the first topic of the first chapter. Then in the next video, we'll see the second topic, that is intelligent agent. Thank you. Okay. So in the first topic, we have covered all these things. Now we'll see what can be the questions and answers that can come from this topic. So the first topic from the introduction to AI, the definition of AI, or what are the categorization of AI. In this, you need to write the formal definitions of AI. Then in your own words, you have to write the definition of AI. Then in the categorization of AI, you have to draw that the 4 dimensions, that system act like human, system think like human, system think rationally, system act rationally, and give the examples of that. That is, for the system that think like human, give the examples of the cognitive modeling approach. System that think rationally, give the example of law of thoughts. Then system that act like humans, give the example of the Turing test. For systems that act rationally, give the example of the rational agent, and mention the dimensions along the diagram. So the top dimension is the thought or the reasoning dimension. The lowest dimension is the behavior dimension. The left dimension is the measure success against human performance, and the right dimension is measure success against ideal concept of intelligence. And explain these 4 categories of AI in your own words. Write down the definitions of what do you mean by system that think like humans. Then give the example of the cognitive modeling approach. Then for system that act like human, give the definition, that is the study of how to make computers do things at which at the moment people are better. So here give the example of the Turing test. For system that think rationally, write down the definitions such as the study of the computations that make it possible to perceive, reason, and act. And here give the example of law of thought. Then give also explain this in your own words and give the example of how the conclusion can be drawn from the premises. That is, suppose a Socrates is a man, all men are mortal, then the conclusion is the Socrates is a mortal. Then for the system that act rationally, the definition is computational intelligence is the study of the design of intelligent agents. Here give the example of a rational agent. Then explain in your own words what do you mean by a rational agent. An agent that acts rationally or does the right thing is called as the rational agent. You can draw the diagram of that rational agent. That is, rational agent perceives the environment through the sensors, then acts upon the environment through the actuators. Then the next one is explain in your own words, that is foundations of AI. The foundations of AI can be also asked. So here you have to first explain what do you mean by foundation of AI. That is a brief history of disciplines that contributed ideas, viewpoints, and techniques to AI. So here explain from philosophy to mathematics to economics, neuroscience, psychology, computer engineering, then control theory and cybernetics, linguistic. That is from the 428 BC to 1957 to present. What are the different foundations of AI? What is studied or what is covered under that foundation that you need to explain. Then history of AI. Then history of AI is how the AI is evolved from 1943 to present. So here you have to explain about the gestation of AI, then the birth of AI, then how the dose of reality is observed, means how the AI is miserably failed when it is tested on some complex problems, then how the knowledge based system or the expert system is designed, then how the AI becomes an industry. Now everywhere, every industry uses the artificial intelligence. Then the return of neural network, then AI becomes a science. The HMM, that is the hidden Markov model, the Bayesian belief network, the data mining is introduced in AI. Then the emergence of the intelligent agents, how the intelligent agents are emerged. All these things you need to explain in history of AI. Then the next question can be application of AI. What are the different applications of AI? So here you can explain the applications as autonomous planning and scheduling. Here you can give the example of NASA's remote agent program to control and schedule the operations for the spacecraft. Then the next application can be a game playing, how the AI is used for the game playing. Here you can give the example of IBM's Deep Blue Chess. Then the application is the autonomous control. Here you can give the example of a Alvin system, how a computer vision system was trained to steer a car to keep it following a lane, how a particular lane is followed using a computer vision system that you need to explain. Then you can give the example of a diagnosis expert system, MyScene, how the database is used or how the expert system responds to the query of the user. That is, the user gives the inputs as the symptoms, then based on the system or the symptoms, how the disease is predicted and how the precautionary actions or certain medications are suggested. Then you can give the application as logistic planning. Here you can give the application of the DART, that is dynamic analysis and replanning tool. The DART is used to do automated logistic planning and scheduling for transportation. Then you can explain the robotics, how the robotics is used in the medical field also and in the vehicles also. Here you can give the example of the HipNav system. The HipNav uses the computer vision techniques to create a 3D model of a patient's internal anatomy and then uses the robotic control to guide insertion of a hip replacement prosthesis. Then the one of the application is language understanding and problem solving. Here you can give the example of a proverb, that is how this proverb system used to solve the crosswords or the puzzle programs. So these are the different questions from this first topic. So I hope this first topic is clear to you, how the AI is evolved, what is the foundation of AI, how we can define the AI, how we can categorize the AI into different dimensions, and how actually we can use the concept of artificial intelligence to develop some intelligent systems. Nowadays, we are having various techniques to design the intelligent system, and everywhere you can see the applications of AI. So in the next topic, we'll see the intelligent agent. Thank you.